Hi everyone, welcome back. Now, projectile motion, quick revision for projectile motion. Let's start. First of all, as you know, we are starting with all definitions. What we have: projectile, free fall, acceleration, velocity, and displacement. Acceleration, velocity, and displacement coming from motion, you know that, but now we have projectile motion. So, projectile, an object upon which the only force acting is the force of gravity. Free fall, any motion of a body where gravity is the only force acting. Acceleration, the rate of change in velocity. Velocity, the rate of change in position. And displacement, the change in position. Done. All definitions here for projectile motion. Let's continue with other things. What we have for projectile motion. First of all, we have free fall. So for projectile motion, we have some important points. Each point is important, notes coming now. But first of all, let's start with free fall. What we know about free fall, you have an object and starting with zero initial velocity. V initial equals 0. And then your acceleration is gravitational acceleration 9.8 meter per second square. This is free fall, drop from somewhere. They said initial velocity is 0. So acceleration of a free falling object is called gravitational acceleration, and symbol is G, value is 9.8. Acceleration is constant. Acceleration is constant. When we are drawing our graph, everything you are going to see, we are using acceleration constant 9.8. Okay, what else? We have same acceleration we are using. Just remember that initial is 0. That's it for free fall. Let's continue with next one. Yes, for projectile motion, we are using these 4 different equations. As you see, first one, V final is equal to V initial plus A times delta T. V final, final velocity, initial velocity, acceleration and time without displacement. And another one without time. If you don't know time in your question, so you are using this equation, and then other equation for displacement, and last one also for displacement. But last one, if you don't know what maybe acceleration is not given, but acceleration is always 9.8. So you can use this one or another one. It's up to you which one is easy for you. So just think easy. Number one, for projectile motion, we are always busy with initial position and final position. 2 points. All right. We are busy with 2 points for all calculations. First of all, just check what is my V initial and then what's my V final. And do we know about delta Y, delta T, and acceleration? You must just think about that. All right. For each question. So maybe you are going to do this one in one question 2-3 times, but always you are busy with 2 questions, not just simple 2 points and calculate. Of course, you are going to calculate here and then asking you another motion, but just simplify that with 2 points, initial and final. When you get V initial, delta Y, delta T, acceleration, or V final, and then one of them will not be given, you are going to calculate. That's it. All right. Just think simple, please. So these definitions we have. And then let's see what else they are saying here, just in object, okay. Let's just check as object project, okay, comes to rest. Final velocity is 0, highest point. Yes, this is the important one. This is another motion. First motion, what was it? Free fall, right? V initial equals 0, we said, and then object is going down. Okay, this is our first motion. But second one, object from ground and going up. So when object going to highest point, V final equals 0. So what we said, just always think you have 2 points, initial position, final position. For this motion, free fall, this is your initial, this is your V final. So this is your final position. V final is here. We are not working with numbers now, just I'm trying to explain how you make it easy. So now, for now, just check, this is your V initial. This is your V final. The initial V final, as you see, just opposite, but because I'm using 2 different equations, 2 different motions. So this is your V initial. We don't know how many meters per second, but you have V initial here. But V final for delta y maximum is 0. V final equals 0 for this kind of motion. All right, so let's continue. Let's see what else we have. Please read, just go through all of them when you have time. All right, note one, important point one. Always choose a direction, positive. All right, so maybe upward motion is positive or downward motion is positive, but you must choose a direction and show that direction by using an arrow. Okay, that's important. Why? Because if you know direction of motion, easy to calculate. All right, for example, free fall. Okay, let's start with free fall. So V initial equals 0, let's say, and then we have V final is here, and then I'm just showing like this. I'm mostly using up positive. Okay, just using like this, up positive. If you say up positive, your acceleration is negative 9.8. Why? Because we know acceleration always downward and always 9.8. So you set up positive and your acceleration is negative. So how we are going to calculate V final? If you have, let's say, for 5 seconds, object is coming ground in 5 seconds. How we are going to calculate? So V final is equal to V initial plus A times delta T. And then V final equals, your V initial equals 0. And we set acceleration is minus. Why minus? Because I know accelerating down, the acceleration always just pulling down. So, but you set up positive. Because of that, acceleration is negative we are using. So minus 9.8 times 5. And your V final is equal to minus what we have, 49, right? 49 meter per second, but you are not living like that with negative. Negative, it always must stay away from us. So V final equals 49 meter per second. Sorry, not square, meter per second, direction down. All right. So this negative is giving you direction because you said upward is positive. And then you got answer 49 meter per second downward. But I will show you, if you choose downward positive, what's going to happen? You should get same answer, exactly same answer. So downward is positive. This is your V initial is equal to 0 and object is going down. And then we are asking you delta T equals 5 meter per second. So sorry, I lost today. Delta T equals 5 seconds. And acceleration is positive 9.8 now. Why? Because I know direction of acceleration going down, always like that, right? Direction of acceleration down. So you said downward is positive. You are showing like this. So you are using positive 9.8 meter per second square. So we are getting V final. So V final equals, V final is equal to V initial plus A times delta T, and V initial is equal to 0 plus 9.8 times 5, and you are getting 49 meter per second. I'll be writing up. Okay. And direction downward. Why? Because you got positive, and then we know positive is downward. Did you get it? I hope it's fine now. So choosing direction is important, but final answer must be same. Okay, using negative and positive just to show direction. If you choose upward positive, your acceleration is negative because I know negative because acceleration always down. I hope it is clear. So same steps to calculate our delta y. So delta y equals, you can use any equation. I will use last one, V initial plus V final over 2 times delta t. And so my V initial equals 0, V final is minus 49. All right. So I'm using that. Why? Because I said upward is positive. So divide by 2 times delta t. Delta t is what? Delta t is 5 seconds. So I'm using delta t. Let's write 5. So 49 over 2 times 5. You are getting your delta y is negative. and then you can say object is coming down. As you say, object is coming down. We are not calculating, but it's fine. So it's coming down, and then you are getting negative. Same steps. If you do this one for choosing downward positive, you are going to calculate delta y is equal to v initial plus v final over 2 times delta t, and you will get positive. So why? Because object is coming down, and then you said downward is positive. I hope it's clear what we said just from note 1. I'm trying to explain note 1, choosing direction. All right, and just show like this. Final answer must be same. Okay, that's clear. Time is going. Note 2, acceleration is constant and always downward. All right, even if they ask you highest point, what's the acceleration? I remember in past paper question they asked. So acceleration is constant and always downward. Remember that. Or moving upward or downward, object is moving somewhere. It's not important. But remember, if you choose upward, upward motion is positive, your acceleration is negative 9.8. We explained in other slide. And then if you just choose downward motion is positive, you say positive because they are having same direction. If you choose downward positive for direction. All right. And then next one, let's continue with next question. Next question is coming. Okay. So next, not question, note 3. Velocity of an object becomes 0 when it reaches the maximum height. Yes, object will be 0 when object is coming to maximum height. Okay, that's our another important point. Okay, that's another important point we just explained now. So if object going up and coming to maximum height, so this position, your velocity, let's say v final is equal to 0 if you choose v initial. Remember, you can choose we are busy with 2 points, right? Always we are busy with 2 points. Maybe object moving from certain height, going up and coming down. So for this kind of questions, you can choose initial position here, final position, that's all. Or you can choose initial here, final there. Or you can choose initial at maximum height, and it's up to you, it's up to your calculation, which one you like. But in this note, they said velocity of an object becomes 0 when it reaches the maximum height. Okay, let's continue. Let's see what else we have. Note 4. Time is a scalar quantity and no direction is used. Remember that. And then if you are getting negative time, it means some calculation is wrong. Just remember that. All right. And note 5. Negative value just showing you direction. Depends on which direction you are choosing, which one is positive. Just remember that. And then let's continue with next one, note 6. Objects at the ground with highest velocity. All right, highest velocity at the moment objects reach the ground. When object is coming to ground, okay, highest velocity, highest kinetic energy. Just remember that. So we can just show, but okay. So object is coming from here, let's say the initial, and then going up, change to 0, and coming down. So when it's coming back, so this position before touching ground, V final equals negative V initial. It means just opposite direction of first one, but same magnitude. If it's going up with 10 meters per second, coming down negative 10 meters per second. Only direction is different, but they have same. And then highest point we have same O. Okay, let's continue with next one. Let's see what else we have. Graph. Yes, from now, we just work on with graph. And then let's see what we have. Uniform motion. What does it mean uniform motion? Acceleration is 0. As you see in our graph, acceleration is 0. Acceleration is 0. Acceleration equals 0. But velocity is constant. You have two options. Velocity is positive or negative. Velocity is positive, your position change to positive. So you are changing position from 0 to, but depends on reference point, which one you are starting, where you are starting. From 0, just increase. Maybe you start from this point, of course, also increasing, but position change positive. And then Another option, your velocity is negative but constant, is you are coming back. Okay, so for example, from 10 meters up, you're coming down to 0 meters. Uniform motion means acceleration is 0, velocity is constant. But another one, for uniformly accelerated motion, now you have acceleration. You have two options, acceleration is negative or acceleration is positive. If acceleration is negative, velocity decreasing, as you see, from 0 to negative. And then if acceleration is positive, as you see, from negative to 0 now. As you see, increasing, all right, velocity increasing. And then your position time graph will be like this, coming, as you see, speed up, and then firstly changing slowly position, finally just speed up, and another one this way. So this is position also change, but making curve, just remember that. Okay, and then bouncing is coming now. If you have one object is coming down, let's say just drop from certain height, okay. So you have just an object from certain height coming down first. After that, bounce up. So what's going on? Just let's show like this. Bounce up, it's coming to second position. Again, it's coming down, bounce up. But each touching time, as you see, position time graph like this. Firstly, speed up and coming down, touch the ground, and waiting just maybe less than second. This one is touching time of contact. So this position, as you see, position never changes, just staying, just let's say 1 second, just staying 1 second and then going up. So just each time getting less high. All right, another touching point here, and another one from 0 to just going down. Okay, just going down, and then another position that's touching somewhere and coming back. So you are just reference position of drop from reference point. So what's the difference between these two graphs? First one, you are choosing this position 0, all right. But for this one, you are choosing certain height. For example, here, just this position. This one you are choosing as 0. If it is your 0 position, object going down. So going down, you set this position 0, and then coming back, coming closer, but not to same height. It's coming up. Another one after call is just coming, just up like this. Okay, so making curve and then changing position like this is our position time graph. And then velocity time graph, what's going on? Firstly, velocity coming to negative. If you choose upward is positive, you say. So velocity getting negative now because the object is coming down. Okay, so this position like this. From 0 and coming down and then going up, but getting less velocity. So contact time we have, if there is no contact straight, you can go up. So the contact, just you can do this one. But firstly, going up because velocity getting positive, because when after touching, as you see, changing direction. When changing direction, change to positive and then coming down and then with less velocity and then again, just carry on like this. If you say downward positive, what's going on? If you just show like this, downward positive velocity, as you see, increasing, velocity increasing, and then when touching ground, changing position, going up now from the point D, as you see, going up. If it is going up, as you see, negative now. Why negative? Because we said downward is positive. So just like this, you can draw your velocity time graph. Some important points here. So V initial is the velocity just before its ground. V initial is here, touching ground position A, point A, and different important points we have, hits the ground at points A, B, C. As you see, A, B, C, touching ground, and then D, E, F, showing you another one. Okay, let's continue. All right, let's continue. This is our velocity time graph. Okay, we have done velocity time graph also. And let's see what else we have. Let's clear all. Acceleration time graph. Acceleration time graph for bouncing, it's happening like this. For example, if it's upward positive, so you are starting with negative acceleration. And then when touching, so as you see, just going up, change to positive and coming down, just like that. And downward positive, you start with positive and then change to negative quickly, a few seconds, and then coming back. This is acceleration time graph. And then let's continue with questions. Let's give examples. Okay, so from now, what you are going to do, please go to past paper questions and I will give you one example, one multiple choice question, and one long question, well, one example for each. So let's see our first question. The graph shows how just one of physical quantity with free fall. Okay, for free fall, as you see, it is constant. For free fall, what we know, what is constant? Acceleration is constant. So what they ask you now, which one of the following physical quantity can be labeled on the y-axis? So what else can be constant? Asking you that question. I know acceleration is constant. It is g 9.8 meter per second squared. So which one depends on acceleration? Velocity. Is it constant for free fall? No. And position constant for free fall? No. Momentum constant for free fall? No, because momentum equals m times v. We know that velocity increasing, velocity changing, momentum also getting different, but weight is constant because weight equals m times g. Mass is constant, g is constant, weight is constant. That's our answer for this question. You can say weights, newtons, and times second. You can draw your graph. All right, I hope it's clear. So let's continue with other question. Long questions coming now. Okay, you have one object, start with 8 meters per second, and then going up to highest point. We know when it's coming to highest point is 0 velocity, and coming down to height 8, and initial position 60 meters. Bouncing from there and going up and coming to ground. So that's our motion. So is the object acceleration at its maximum height, upward, downward, or 0? What we said, acceleration always downward. That's it. First answer is downward. And then next question. Calculate the magnitude of the velocity at which the object strike the balcony. So we are looking for velocity for this point when touching the balcony. Okay, let's show this position velocity we are looking for. How can we calculate? We have different options for this question. We have too many options. Let's see. Upward positive. If you say upward positive, you can use this way. V final is equal to V initial plus A times delta T. What we said, we remember, always choose your 2 points. First point, your initial position. First point is your initial position. Second point is your final position. Object is going up and coming. If you want, you can choose, this is my final position, calculate something there and coming, but easy way, it is my initial position and this is my final position. So for initial position, what's my V initial? Is 8 meters per second. On the diagram or on your solution, if you write like this, it's going to be very easy for you. I am looking for V final for this point. V final we are going to calculate. What else I know? If I say upward positive, you can write like this, upward positive, or you can show just with arrow and sign, also fine. If upward positive, what I know? Acceleration is negative because acceleration always down, and then you said up is positive. So you are using negative, and then you are getting negative 31.2 using first formula, V final equals V initial plus A times delta T. I am using these 2 points, and then V final equals minus 31.2, because as you see, finally you are going down. So as you see, direction is this way. This arrow showing you after bouncing is going up, all right? So you are using this one, let's show, going up and coming down. So this is your final position. All right, I hope it's clear. V initial, V final, delta T already given. They said after 4 seconds coming to height h, 4 seconds we have. V initial we know already, 8 meters per second. Positive I'm using because direction of motion and direction of velocity V initial and direction of, you said positive, upward positive. All right. So if you say downward positive, what's going to happen? V initial is negative now. Why? Because you are saying downward positive. Okay, let's use downward positive. So object is going up initially. So negative 8. But your acceleration is positive because acceleration always down. So you are getting 31.2. As you see, you are final, you are getting same answer. Just remove if you get negative. Remove and say. And if they said magnitude, because of that, you don't have to say direction. But if they don't say magnitude, just calculate velocity. What we have to say, you get positive, so negative answer. Because of that, you should say downwards. All right, for this answer, just say downward. And now you get positive, but you said downward is positive. So answer is downward. So you are just getting same answer, even same direction. I hope it's clear. We are using our first equation. What we said, 2 points important for you, just using initial and final. All right, let's continue with next one. Okay, let's see what else they're asking you. Now asking you to calculate that height. Okay, this height we are going to calculate. How we are going to calculate that? One more time. I am choosing my 2 points. Okay, now which 2 points I'm going to use? This is not A by mistake. We wrote A. This is V initial. All right, V initial. Even this one, let's change it. V initial. Okay, so now, as you see, in 4 seconds coming down, I'm using delta Y for this one. Okay, for initial same motion, same 2 points I'm using, calculating this delta Y. When you get this delta Y, just subtract from 60 meters, because just you are calculating the another equation I'm using. So this is my initial point, this is my final. If you say upward positive, your V initial is positive, delta T already positive because always positive, and 1/2 times negative 9.8 because you said up positive. So you are just calculating negative 46.4 and 60 minus 46.2 because delta Y, forget about this negative one, just showing you directions, remember that? So 60 minus 46 and you are getting 13.6. Another one, if you say downward positive, V initial is negative now, remember other question, and times delta, just times by 4, and acceleration is positive now, but, and then you are getting your, you should get positive, sorry. Okay, you are getting positive because you said downward positive. So mistakes, 3 mistakes in this question. Okay, and then you are getting 46 minus, so 60 minus 46.4. I hope it is clear. So please think simple and make it simple and get your answer. Use 2 points, initial and final. Even if they are giving you 2 different objects, first one, second one, just separate them, calculate different. Okay, just use, okay, for A, what's my initial position, final position, get something, calculate, and then maybe you can use that one for another object, but same process for all questions. Okay, let's continue with next one. Now we are going to draw graph, velocity time graph. So object bounced from balcony 27.13 meters per second, all right, and then in 6 seconds, okay, coming to ground. Okay, so they're asking you draw graph. Let's see our graph now. I think we have done after this. Yes. So now we are drawing what we know. Initial velocity is 8, and then velocity coming to 0 because going to highest point. This point is highest point. This is my highest point, and then coming down from highest point to negative 31.2, we calculate in 4 seconds. See, this is my first one. And then strike and going up. So going to 27, because they said after bounce, it's coming to 27.13 meter per second. So coming to positive, after that, it's going to 0 again. So this motion we can show with our diagram. Okay, it's coming back, and then in 10 seconds complete, or because they said after bouncing 6 seconds, 4 seconds already gone, extra 6 seconds, total 10 seconds. Firstly, maybe we can draw. Firstly, you start with 8 meter per second. Okay, let's try to draw here. This is my point, just height 8. Firstly, starting with 8 meter per second up, we said upward positive, so now you have positive 8, and then going to 0, because highest point we know it is 0, this is your highest point, and then coming down to H, this part on this position. We know it's touching that level with 31.2, negative, because direction is negative, up is positive, we said. So, and then it's bouncing with, they said, bouncing with 27.13, it is given. So this is my V initial for this point. And then going up again, change to 0 and going to ground. I hope it is clear. Just this change, remember, was because direction getting different, direction getting opposite direction, all criteria to get full mark. Please draw your graph nicely. All right, we have done for today. Projectile motion also done. See you next lesson.